4.2b is on systems of linear equalities. So we are going to graph two linear equalities and figure out what the solution is. So right here in the corner we have an example of what this would look like. So when we're talking about our linear inequalities, remember we graph the line in slope-intercept form like we always would have. If it's equal to, it'll be a solid line, right? Greater than or equal to or less than or equal to is a solid line. Less than or greater than is a dashed line. Okay, if it's less than, we shade below. If it's greater than, we shade above the line. And remember, we need to have y isolated before we can graph. So we are going to start off and we are going to graph these systems. In order to do that, we're going to start off and we're just going to look at this first equation. So we're going to graph y is less than or equal to 2x plus 3. Well, let's start it off with our y-intercept of positive 3. Here's our y-intercept, and then our slope is 2. So we're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. And then we have to fill in our whole line because it has to be very accurate when we're shading, right? When we're shading to find our solutions. So now we have our points. Since it's equal to tells us that it's going to be a solid line. So the last thing we have to ask ourselves is, do we shade above or below? Well, this is a less than sign. This is a less than sign, so if we wanted to, we could pick a test point. We could pick like 0, 0 as our test point. So is 0 less than or equal to 2 times 0 plus 3? Well, that's just asking, is 0 less than or equal to 3? Yes, it is. So we would shade in the area where the origin is. Notice how I just shaded very lightly. I just shaded very lightly. So I just shaded enough so I know that this bottom half of the line, right, this half of the graph is where my solutions are. Now, we are done with that first equation. So once we're completely done with the first equation, then we're going to go and we're going to do the same thing for the second equation. So we're going to pretend like our first equation isn't on our graph. So we have y is greater than or equal to x minus 1. So we're going to graph our y-intercept of negative 1, and then we have a slope of 1, so we're going to go up 1 over 1, up 1 over 1. And again, we're going to fill the entire thing in because you need to be very accurate when finding these different areas, these different regions. So here's our slope. Since it's equal to, it's going to be a solid line. So we're going to connect all of our dots with a solid line, and then we need to figure out where to shade. Okay, where to shade for this. So y is greater than or equal to x minus 1, so since it's greater than, we're going to shade above this line. But if we're not sure where above is, we could always take that test point. Since our line isn't on the origin, we could test 0, 0. If our line was ever passing through the origin, we would not be able to use that as a test point. You can only use points that are not on your line as test points. Well, our test point says 0 is greater than or equal to negative 1. That's true, so we would shade everything that is above the green line. So our solution for this system is the area that our lines have in common. So if we're looking, notice that this area right here has purple shading in it and it has green shading in it. So since this one little section right here has both colors in it, then this section is our solution. So anything on either of these lines, since they're solid, and anything in this yellow area is a solution to this system of equations. So if we wanted to list 3 possible solutions for this linear system, we would pick any 3 ordered pairs from this area. So for example, the origin is in this area. I kind of colored over all of my points, but it looks like the point 2, 2 is in this area, and it looks like the point, let's see, 3 and up 8, so 3, 8 is in this area. And you could have picked any ordered pair in that area, because any ordered pair in that area is a solution for this problem. So let's try another one. Remember, we're going to graph our equations completely separately, and then we're just going to figure out, well, what shaded area do they have in common? Because the shaded area they have in common is our solution. So notice for letter B, neither of our equations is in slope-intercept form, so the first thing we have to do is solve them for y. Well, if negative 2y is less than 4x, we can just divide by negative 2 to solve, which would leave us with y. Since we divided by a negative, our sign needs to flip. Y is greater than 4x divided by negative 2 is negative 2x. Y is greater than negative 2x. So let's just graph that to start with. Well, we don't have a constant, so our y-intercept would just be 0. And then our slope is negative 2, so we're going to go down 2 and over 1. Down 2 and over 1. Since it's a negative 2, that's why we go down 2 to the right 1. And remember, you always go to the right. Doesn't matter if it's positive, negative, you always go to the right, because the positive or negative tells you if it is up or down. Then, looking at our sign, it is not equal to, so we'll just have a dashed line. We'll just dash our line in very lightly, and then we just need to decide what area to shade. Well, we could test a point. Notice that we can't test the origin because our line is on the origin, so we would have to pick a different point. So I'm going to pick the point 1, 1 to test. Here's my test point of 1, 1. Well, I'd plug 1 in for y and 1 in for x. Well, is 1 greater than negative 2? Yes, it is. So all of our solutions are in this area. And again, I'm going to shade very lightly, just enough so I know what side of that line is the solutions. Now that we're done with that, we're going to go to the second equation. 2x plus 3y equals 6. Well, we want to solve for y. So we can subtract 2x from both sides. So we have 3y is less than or equal to a negative 2x plus 6. Well, we can divide everything by 3. So y is going to be less than or equal to negative 2/3 x plus 2. And notice we're going to leave negative 2/3 as a fraction so we can use it as our slope. So we have a y-intercept of positive 2. Remember, we're just going to pretend like that other equation isn't even there. So we have a y-intercept of 2, and then we're going to go down 2 to the right 3. Down 2 to the right 3 to fill in our line. If we want to do the back half, we'd go up 2 and back 3. Up 2 and back 3. Up 2 and back 3. Since it's got that equal to, that tells us that it's a solid line. So we're going to connect all of our points with the solid line. And then we just need to test an area. So notice that this blue line does not pass through the origin, so we could use the origin as our test point. So if we have 0 in for y and 0 in for x, let's see what happens. Well, this is just 0, so we'd end up with 0 is less than or equal to 2. Well, is 0 less than or equal to 2? Yes, yes it is. And so we would graph, or we would shade everything below that line, okay? Which makes sense because it was a less than or equal to sign. So then looking at it, hopefully you notice which area, right? Which area has blue and red shading in it. It's this corner right here. So that would be our solution. Everything on the blue line and everything in that area would be our solutions. So you can go ahead and list 3 possible solutions of this linear inequality. Anything from this shaded area would work. So for example, let's see, the point 2, 0 would work because that's in our shaded region. We're going to look at a couple more examples. Letter C, we have y is greater than or equal to 3. So we're going to put 3 on our y-axis. Okay, and then since it's just y is greater than or equal to 3, we're going to have a horizontal line. Since it's equal to, it will be a solid line. And then we need to figure out where to shade. Well, it says y is greater than 3, so greater than 3 is everything above that line. And then we want to shade x is less than negative 5. Well, here's our x-axis, so let's find negative 5 on our x-axis. Right, since this is on our horizontal axis, we know our line will be vertical. Since it's not equal to, we know it'll be a dashed line. And we want to shade everything that's less than negative 5. Well, if we think about it, what numbers are less than negative 5? Well, negative 6, negative 7, negative 8 are less than negative 5. So we would shade this left half of the line. So this left half of the line is our solution for our blue line. So that means this corner right up here. Anything in this corner, that is our solutions for this particular set. So you could pick any 3 ordered pairs from that corner, and those would be your possible solutions. So we could pick, let's see, negative 9. 9 is in that corner. 10, negative oops, negative 10. Positive 10 is in that corner. All right, one more. How about the point? Negative 6, positive 4 is in that little shaded region. So those are 3 of the possible solutions in that area. Last example would be a good idea to pause and try this out. So we have D, for letter D, y is greater than negative 2x plus 5. So let's start off by graphing that. We have a y-intercept of 5, so we're going to find 5 on our y-axis. And then since our slope is negative 1/2, we're going to go down 1 to the right 2. Down 1 to the right 2. And notice how when we do that, our line is decreasing, which is what should happen since it is a negative slope. Well, it's not equal to, so we're just going to kind of dash our line in. Right? It's not a solid line, it's just a dash line. And then where should we shade? So we could do our test point if we wanted to, but we want to shade everything that's greater than. So again, you can do a test point if you want to. So it would be 0 is greater than, well, negative 1/2 times 0 would just be 0. So is 0 greater than 5? 0 is not greater than 5, so we wouldn't shade the area with the origin. We would shade the other area. Then, now that we're done with that line, we'll go and we'll do the second line. Y is less than or equal to negative 1/2 minus 4. Well, here's our negative 4 on our y-axis. Slope is still negative 1/2, so we're still going to go down 1 and over 2. Down 1 and over 2. And then to fill in the back half, we'd go up 1 and left 2. It's equal to, so we are actually going to connect all of our points. And then we could do our test point of 0, 0 again, since our line isn't passing through the origin. So again, this negative 1/2 times 0 is just gone. So is 0 less than or equal to negative 4? Well, 0 is actually greater than negative 4. So we're going to shade on the opposite side from the origin. Now looking at this, is there any area that is overlapping? No, there's not. There's no common shaded area. So since there's no area that they have in common, we would say there are no solutions. So if that ever happens where there's no area in common, we would call that situation no solutions, and that would be our answer for it. So for two inequalities, you want to make sure that y is by itself to graph. We're still doing that solid or dashed line based on if it's got the less than or equal to and greater than or equal to. We still test a point. Origin is really easy unless your line is actually passing through the origin. And last but not least, your solution, right? Your solution is just in that shaded area where they meet. And